Photizomed Tutorial is a medical learning hub for all preclinical students. We are committed to achieving excellence in med school with ease.
Transforming the medical field by imparting you with the knowledge to be the best in your field.
We've all felt it, right? From a tiny paper cut to something way more serious. It's this universal human thing, but at the same time, it's also incredibly personal and, surprisingly complex. Even with all our amazing medical tech, we are still just scratching the surface of its deepest mysteries. So that brings us to the most basic question of all. Why? If it hurts so much, what is it even for? Well, it turns out that pain is actually one of the most important systems our body has. But it's a system with two very, very different faces. On one hand, pain is our guardian. It's the alarm that screams, "Hey, pull your hand away from that hot stove," before you get a really serious burn. It teaches us what to avoid. It protects our joints by making us rest when they're injured. But on the flip side, when that system goes haywire, pain becomes an absolute tormentor. It can be more debilitating than the injury itself. Okay, so let's get into the mechanics of this. To really understand pain, we have to follow the signal. We're going to trace its lightning-fast journey from the very moment of injury all the way up to the brain. It all starts right here, with these things called nociceptors. Just think of them as these microscopic danger detectors scattered all over your body. They're specialized nerve endings, and they have one job: to detect potential or actual damage to your tissues. Whether that's from a cut, or intense heat, or a chemical burn, when they're triggered, the alarm gets sounded. So once that alarm is triggered, the message has to get to your brain and spinal cord, right? And it travels along two main types of nerve fibers. Think of it like having two different internet speeds for your body. The A-delta fibers are your high-speed fiber optic connection. They're big and coated in something called myelin, which acts like insulation, letting the signal travel incredibly fast. They deliver that first, sharp, stinging pain that makes you instantly yelp, "Ouch!" Then you've got the C fibers. They're the slow, dial-up connection. They're unmyelinated and smaller, so they carry the signal for that delayed, dull, throbbing ache that kind of sets in afterwards. So you've got both of these signals, the fast one and the slow one, and they race from the site of the injury right into your spinal cord to an area called the dorsal horn. Now this place is like a critical relay station, because before the message even gets all the way up to your brain for you to consciously feel pain, an immediate reflex can be triggered right here. It tells your muscles to pull away from the danger. That's exactly why you yank your hand off a hot stove before your brain has even fully processed what just happened. Now, for a long time, scientists kind of thought pain was just a one-way street. You get injured, the signal goes to your brain, you feel pain, end of story. But then, in 1965, a totally revolutionary idea came along and changed everything. It's called the gate control theory, and it suggests our bodies have this incredible ability to basically turn the volume of pain up or down. So here's the absolute game changer. The transmission of a pain signal is not a sure thing. Your body has what you can think of as a gate in the spinal cord that can literally block that signal from getting through to the brain. And the key to controlling that gate? Other sensory information. This slide explains something we all do instinctively. Why do you immediately rub your elbow after you bang it on a table? Well, it's because that rubbing sensation travels on other, faster nerve fibers. These are called A-beta fibers. This non-painful sensory info gets to that spinal gate first and essentially closes it, which blocks the slower pain messages from the A-delta and C fibers from getting through. You are literally interrupting the pain signal with touch. And this is where it gets really wild. The gate isn't just controlled by physical touch. Our emotional and mental states have a direct line to the control panel. Things like anxiety, worry, or just focusing really intensely on the pain can actually hold the gate open, making the sensation feel way worse. But on the other hand, positive emotions, relaxation, or even just being distracted by something interesting can help close the gate, reducing how much pain you actually perceive. It's not just all in your head, it's literally how the system is wired. So this pain system is an amazing alarm, but what happens when that alarm gets stuck in the on position? This is where we run into the huge difference between pain that helps us and pain that really, really harms us. Acute pain, that's the body's normal, healthy response. It's a direct warning about an injury, and it goes away as you heal. It serves the purpose. Chronic pain, though, is a whole different beast. It's pain that lasts for months, long after the original injury should have healed. At this point, the pain itself becomes the disease. The nervous system can actually get rewired and become hypersensitive, firing off pain signals without any real trigger. It serves no protective function, and it can completely change a person's life, often leading to things like severe depression. Because pain is so complex, it's probably no surprise that it shows up in a lot of different ways. It all depends on what part of the body is affected and which part of the nervous system is sending out the signal.
So first up is the one we're all most familiar with, somatic pain. This is the pain from your body's outer shell, basically your skin, muscles, joints, and bones. Think about a sprained ankle, a tension headache, arthritis. It's usually pretty easy to point right to it and say, it hurts here. We usually describe it as sharp or dull or aching. Yeah, a classic example would be shoulder pain from pulling a muscle. The pain is located right there in that tissue, and it gets worse when you try to move it. It's a pretty straightforward signal coming from a very specific location.
Visceral pain is different. This kind of pain comes from our internal organs. And because there are way fewer of those danger-detecting nociceptors inside our organs, this pain is often really vague and diffuse and hard to pinpoint. It's that deep, dull, sometimes crampy ache that you just can't quite put your finger on.
So when you feel this kind of pain from your stomach, your intestines, other organs, it's usually felt over a really wide area. And sometimes, even weirder, it's felt somewhere else in the body entirely. That phenomenon has a name. It's called referred pain.
And then you have neuropathic pain. This is what happens when the nerves themselves, the body's actual wiring, are damaged or just not working right. The pain signal is basically a fault in the system. It offers no protection at all and is often described in totally different ways, like a burning or shooting or stabbing sensation, or that pins and needles feeling.
Okay, this is where it gets really mind-bending. This slide explains that referred pain we just mentioned. Signals from your internal organs, say your heart, travel to the spinal cord along the exact same nerve pathways as signals from your skin and muscles, like your arm. So the brain, it gets its wires crossed. It's way more used to getting signals from the arm, so it misinterprets the danger signal from the heart as pain in your left arm. It's a pretty profound example of how pain is an interpretation made by the brain, not just a raw sensation.
And if you want the ultimate proof that pain is constructed in the brain, look no further than phantom limb syndrome. After an amputation, the brain's internal map of that body part still exists. An amputee might feel their missing arm swing as they walk or feel it get stuck in a painful, awkward position. This is not imagination. It's the brain generating a real, tangible sensation for a body part that is no longer there. It's probably the most dramatic proof we have that all pain, ultimately, is an experience created inside the brain.
This quote really just gets to the heart of it, doesn't it? Pain, especially when it becomes chronic, can just overwhelm everything else in life. Albert Schweitzer understood that it's not just a physical sensation, but an experience that can completely dominate a person's entire existence.
And that leaves us with a final thought to chew on. We've seen that pain is shaped by our thoughts, our emotions, and our focus. It's an invisible, completely subjective experience. So the next time someone tells you they're in pain, just remember the complex, weird journey that signal has taken. It's a reminder that empathy might just be the most powerful pain modulator we have.